Work is the amount of energy added to an object as a result of the forces acting on it. And the work is given by the following formula. So it's the integral of the force with respect to the path travelled, where the path is given by dx. So if you're going to put limits, you would have your starting point would be A, and B is your final point there. Now note, there is one other important part to this equation, and that is that there's a dot in between the two. And this dot is a new operator, which we will explore, called the dot product. Now the dot product applies to vectors, and the dot means to take the component of the vector which is parallel with the other vector. And this is because work is only done if the force has a component which is parallel to the path over which the force is applied. Let's have a look at 3 examples. Our first 2 examples will relate to a tennis ball which is being thrown and caught. So example 1 is when you throw the tennis ball. So let's imagine we've got our ball over here and somebody's applying a force to it in this particular direction to speed it up. Now that won't happen instantaneously, they'll keep pushing it over a small period of time. It might be some fractions of a second, but that ball will be experiencing a force that's in the same direction as its movement, or the same direction as the path over which the force is applied. So in this case, the F and the dx are in the same direction, and that means you're going to get a positive amount of work done on the ball, and the kinetic energy of the ball will increase. For our second example, we're going to look at when the ball is caught by somebody, so when somebody catches that ball. So in this particular case, the force is actually being provided in the opposite direction against the movement of the ball. So, if the ball is moving really fast, the person won't just catch it all at once. Instead, the ball will gradually slow down as they move their hands backwards. And so, that means that the force is actually in the opposite direction to which the ball is moving, or the force in the opposite direction to the path over which the force is applied. And so in that particular case, F and dx are in opposite directions, and this will result in negative work being done, and the kinetic energy of the ball will decrease. For the final example, let's imagine a toy train that's moving along a track, and I try and push it sideways to its movement. So shown from above, these are the train tracks, and this is my train's direction of movement as it's on the tracks, and then I'm going to provide a force in this direction here. So in this particular case, there's no parallel component of the force in the direction of the train's movement. So this means that no work is being done on the train, and that means that the speed will actually be completely unaffected by the force being applied.